Today let us solve a problem in vector algebra, that is a real-time problem. A flight is take off from point A and landed at point B. Let us find answer for these two questions. Number one is how far flight travel from path A to B and what direction the flight ends at B. So in this question they have provided the three location coordinates, that is the xy axis points, that is between point A and point B flight travel to a location x and to a location y. In the x location we have a coordinate of 5,7 x and y axis, and when it reached the y location we have two coordinates 8,11, and at B we have two coordinates, that is 12,30. By using this three coordinate system, how are we going to apply the vector algebra to find the distance as well as the direction of this particular flight? So here let me put it in a well-defined drawing. So on the top left corner you can see the actual diagram of the flight path A to B, and on the right side I redraw that for the purpose of understanding. So from the A point to B point, I consider the A point as an origin from where it's first moving to 5 to 5 by 7 location coordinate, and then 8 to 11 location, and 12 to 13 location. So when we are adding the total x direction, here we want to find the total distance traveled by this flight. So first we need to find the x-axis distance, that is adding all the x values, and then we need to find the y-axis distance by adding all the y values. When we all add all the x values, we get it's 25 nautical miles, as you can see on the screen, and when we are adding all y-axis we get 31 nautical miles, that is in the y-axis. So by using these two values, now we want to find the distance traveled from point A to point B, that is I mentioned here as TD, which is the total distance traveled by this flight. I'll show you how to calculate this TD by using Pythagoras theorem. Here I am again redrawn the same x-axis and y-axis distance and applying the Pythagoras theorem to find the actual distance traveled by the flight from the point A to the point B. Okay, so by taking the Pythagoras theorem, TD, as I told earlier, it is a total distance. So the total distance is the square root of the adjacent two sides gives the hypotenuse. So that's the formula of Pythagoras theorem. So the TD square equal to 25 square and 31 square. So when we are square rooting both the side, we find the answer 1586 square root, which gives the final answer. Total distance is 39.8 nautical miles. NM means the nautical miles, which is the unit for the flight. All right. From the previous slide, we found the distance from the flight path A to B. It's 39.8 nautical miles. In this slide, we are going to see how to find the direction of the flight, especially the degree, what degree it's traveling. So we use that formula, and it's very easy. Tan theta is the simplest formula to find the direction, that is a tan theta equal to opposite by adjacent, so theta equal to tan inverse of opposite by adjacent. As we know that the opposite direction is 31 nautical miles and the adjacent is 25 nautical miles. All right, so when we are taking the ratio of these both, we found it's 1.24 tan theta, and theta equal to tan inverse of 1.24 gives you 51.1 degree. I'm rounding up the 10th place, so it is traveling for 51.1 degree, which is the first quadrant, and it's traveling towards the north, as you are seeing the right corner below the final drawings of flight path A to B, which is traveling. So this is 51 degrees traveling. This is how we are using the both the magnitude and direction from the given coordinate system to find the flight path distance as well as the direction of the flight. If you have any doubt, please comment below in this video, and you can subscribe to my YouTube channel. Okay, thank you.